All right, so part B, you might have noticed I didn't say pause me to copy this stuff. I'm gonna stop doing that from now on because it's taking up time and these videos are limited to 15 with this recording method. So just pause me at the beginning to copy this stuff and then every time I scroll. So inverse matrices. A singular matrix is a matrix whose determinant is 0. And a non-singular matrix, you'll never guess, is a matrix whose determinant, I wrote is a matrix twice. You don't need to write is a matrix twice. A non-singular matrix is a matrix whose determinant is non-zero. And if the determinant is non-zero, then that matrix has an inverse. Okay, so singular matrices do not have inverses. Non-singular matrices do have inverses. So how do we find an inverse? We take the matrix and we place it next to what's called the identity matrix. So there is an identity matrix for each square matrix. The identity matrix has ones along the diagonal and zeros everywhere else. And you might remember that that's what our goal is when we're doing, when we're getting a matrix into reduced row echelon form. Okay. So this is called the identity matrix. So we place the matrix itself next to the identity matrix. Then we perform row operations to transform the left side into the identity matrix. The result ends up being the inverse, but we'll talk about that in a second. So we want to get the left side to be the identity matrix. So basically we're getting the left side into reduced row echelon form. So we're going to take our row 1 and we're going to multiply it by 1/3. Same rules as before. I think this was 2 sections ago. We want to start by getting a 1 in the top left corner. So we need to multiply by 1/3. There's an easier way to get a 1. Okay, so these are the things that I want you to think about. I don't want to have a negative 1/3 there. That's yucky. Then I have to deal with fractions. So instead of doing that, let's back up a second and be smart here. Can you see a different way of getting that top left corner to be 1? If I add R2 and R1, 3 minus 2, let me use my cursor. If I add these together, I get 1. And then when I add these together, I don't have a fraction. So I'm happy. And we go all the way across. So whatever we do to the row, we do to the entire row. So I'm going to add these together and I'm going to add these together. Okay, so that's my new row 1. And if I'm lucky, that 0 is going to stay there and make my life easier. Make my life easier when I'm getting this left side to be the identity. So remember what we did. I think it was, like I said, I think it was 2 sections ago. First goal is to get that top corner to be a 1, and then we want to get 0 underneath. So I need to figure out what I'm going to do to my row 2 to get a 0. So I'm going to have a new row 2. We're always using the one that we just created to create the 0 that we're trying to get. So I'm going to go 2 times row 1 plus row 2. So just like I did last time, you might want to write 2 times row 1. So 2 times row 1 is the green. I should have probably I just realized I could have color coded it for you guys in the last, I don't know if it was the last video. I'm going to combine those and I'm going to get what? 0, 1, 2, 3, right? I'm not doing anything to row 1. And lo and behold, this problem is actually working out nice for us because now this is the identity and that was our goal. Okay, so as soon as we get the left side of this matrix system to be the identity, then the right side is the inverse matrix. So the answer is that right side matrix, okay? Now, here's a way to check. So I'm going to do this in a completely different color. A way to check our work. A times A inverse and A inverse times A should equal, oops, you can't see that, sorry, should equal the identity matrix. So you can check it both ways if you want. I'm just going to check it one way. So I'm going to go and this is good to practice the multiplying that we did in the last video anyways, okay? So this is just checking the work. You don't have to do this. I would encourage you to, if you have any doubts, if you get weird answers or anything, I would encourage you to check it. So remember, the number of columns that are in the second. So there's 2 columns. I don't know why I can't talk while I'm choosing a color. Whatever. The number of columns in the second is how many times I write the first. So I'm going to write the first matrix 2 times. And then I'm going to use this first column. And I'm going to turn it on its side. And multiply those together. Remember, we're adding those. And then I'm going to take the second column and turn it on its side. Adding those. And that is my answer. So I'm going to go, you know what, I'll show the work like I did last time. 3 minus 2, right? Doing the multiplication. Negative 2 plus 2. 3 minus 3. Negative 2 plus 3 ends up with the identity matrix. So that checks out. We're all good. That's how to find an inverse. All right, so what do we need inverses for? We're going to use inverses to solve an equation. So first, I'll talk about the inverse algebra in a minute. The first thing is we need to be able to write this system. I think we talked about this on the very first day of matrices. Being able to write the system in matrix form. Now, the coefficient matrix is called A, capital A. The variable matrix is called X, and that's a capital X. And then the constant, the thing after the equal sign, is called B. So off to the side, we're going to get back to this in a minute. Off to the side, we have something like that. AX equals B. We're going to take the A matrix and we're going to find its inverse. So we take the A matrix and we put it side by side with the identity matrix, just like we did before in the previous problem. So this work that we're doing right now is literally exactly the same as the previous problem, and then we're just going to add a step. So we want to find, remember our goal is to get the left side of that to be the identity. So now I'm going to make a recommendation. I could get that top left 6 to be a 1. Of course I could, but it's going to be yucky. I'm going to have to multiply by 1/6, and then I'm going to have yucky fractions. So I'm going to say for your first step, I recommend interchanging row 1 and row 2. Because now it's a lot easier to get the 1 in the top left. So first goal is to get the 1 in the top left. So my new row 1 is going to be half of my old row 1. And yeah, I'm still going to have a fraction in there, but it's not going to be 5/6 and 1/6 like it would have been. It's just going to be a 1/2. So I'm multiplying by 1/2. Not doing anything to my row 2. Now I want to get 0 underneath. So underneath the 1, remember that we're always using, I feel like I've said this, I feel like a broken record. We're always using the 1 that we just created to force our 0 that we're trying to get. We're going to do -6 times row 1 plus row 2 to get the 0. So I'm going to write -6 times row 1 below, and then I'm going to combine those. What do I get? 0, -1, 1, -3. Oh, I'm really close. Okay. So do you remember the next goal? We didn't have to do it in the previous example because we ended up with the identity right away. So we do a 1 in the top left corner and then 0 below, and then we follow along the diagonal. So I want my new row 2 to be the opposite of the old row 2 so that I get a 1 in the along the diagonal, a second 1. Let me just double check that I didn't make a mistake there. Okay, I think we're good. And then the last thing we want to do is get a 0 above that so that we have the identity. So we're going to change row 1. We're going to, again, 87th time I've said this, we use the 1 that we just created in the bottom right corner of that first matrix to create the 0 that we're trying to get above it. So we're going to use the row 2. The 1 that we just created is in row 2. If we multiply it by a negative and add it to row 1, then we end up with 0. So you probably don't need this, but just to be safe, we're going to multiply row 2 by -1. And then we're going to add those together. So -3/2, -3 is the same as -6/2. So adding that together with 1/2. So that's our new row 1, and then the row 2 is staying the same. So just like before, this is now the identity, which tells me then this is A inverse. Okay, so I'm going to scroll. We're going to have to scroll back and forth, but let's look at what's happening here. We have the A. I need a little space between, so I'm going to move the B over a little bit. Oh, that's a different marker. That's fun. Okay, so what we're trying to do is we're trying to get the X by itself. We want to know what X and Y equal. So we're trying to get the X by itself. I can multiply both sides of this matrix by A inverse. Now the tricky thing is if I multiply in front on the left, I have to multiply in front on the right. Okay, so these cancel each other out and I end up with X equals A inverse times B. So my XY matrix is going to, let me draw a little line here. My XY matrix, I want to take that A inverse that I just found. So 1, -1, -5 over 2, 3. And multiply it by the B matrix. So I want you to pause me and do that multiplication on your own. And then I'll show you the answer. All right, so here's your multiplication work. Do the arithmetic, and you end up with 2, -1 as your solution to this system.